Hi all, I am V3TLD. This is my home-route 20 watt QRP transceiver based on Radioberry SDR and assembled on a stacking topology. 4 PCBs are stacked on top of one. The 4 PCBs are a 20 watt power amplifier, low pass filter board, Radioberry and a Raspberry Pi 4. Out of this, 3 PCBs are credit card sized and Radioberry is even smaller. I will show one by one and assembly of these 4 boards. First is a 20 watt PA board based on a G6 ALU design. This is on a credit card size PCB done by me. MOSFETs are mounted on the back side of the PCB. The heatsink used to mount MOSFET is 100 mm by 56 mm by 30 mm heatsink. On the heatsink, 2 fans are also mounted. Altogether, 3 fans are used for this QRP. I have maintained a gap of 30 mm between power amplifier board and LPF board using spacers. Next is the LPF board, which is based on N2 ADR design. A DC-DC buck converter from 13.8 to 5.1 volt is incorporated on this board, which can deliver 3.5 ampere of current with a very low ripple voltage. Typically, I can say around 15 millivolt. This can be used for powering Radioberry and Raspberry Pi so that the transceiver can be powered with a single 13.8 volt source. A backside of LPF board have two 3.5 mm audio jack and one RJ11 connector mounted. One audio jack is used for 3W paddle and the other one is used for PTT in and CW. This is the Radioberry board itself, a wonderful low-cost high-performing radio designed by Johann Mas PA3 GSB on a very small footprint. And this is the 2 into 10 pin connector which is connecting between Radioberry and LPF board. This is the 5.1 volt output from DC-DC converter and is fed to a 3.3 volt regulator for powering LPF board. Now on this one, Raspberry Pi 4 will be attached and one fan from the side. It is a 50 mm by 50 mm by 10 mm fan. That's all. And this is the 12 volt connector for fans, 3 fans. This is powered by a 12 volt regulator which is mounted on the power amplifier board. And these are the plots of LPF measured using nano VNA. I have done some comparison of noise floor with the different power supplies. Power supply means first one I have used a Raspberry Pi power supply. This time I have removed that DC-DC connector. You can see it is removed from that. Now this is with the Raspberry Pi power supply. And now that RX gain it is set to 0 and you can see it is coming. It is RX gain, you can see it is set to 0 and noise floor it is coming uh, between 115 to 110, around 110 dBm it is coming noise floor. This is with the Raspberry Pi power supply. Next I am using MI's power bank, battery power bank. Now also it is DC-DC converter is removed. Now this is with MI power bank. Here you can see that the noise floor has come down to minus 20 dBm around noise floor. Little bit above minus 20, minus 22 point, minus minus 117.5, something like that. Between 115 and 120. Now I'll be connecting the internal DC-DC converter. I've connected back the DC converter. Now I am powering using 13.8 volt connector. This is the 13.8 volt connector which is mounted on power amplifier board. Here you can see that the noise floor is at minus 120 dBm line. It is almost equivalent to the MI power bank. So it is this internal DC-DC converter is better than a Raspberry Pi power supply. Thanks for watching.